welcome back. So in this video, we're now in section 15.3. In this video, I want to show you how to deal with what they call moving averages. So here, so in the last video, we just took the average of everything. But now what we're going to do is we're going to have this moving average. So instead of, like the average of weeks 1 and 2 being the estimate for week 3, we're going to use a 3-period moving average to estimate all of our sales. So the first, for example, in this case, so this all comes from page 479 to 452. And what I'm going to do is try to replicate table 15.9 for you using this 3-period moving average. So here, so what we're going to do is we're going to use the previous 3 periods to estimate the sales in the next period. So again, I'll call this my moving average forecast. Okay? And so if I'm going to use 3 periods to forecast sales in the next period, I have to start in week 4, right? Because this is, I need the first 3 periods. So get the average function and just take the average of these first 3 periods. And that will be my estimate for my week 4 sales. And now the nice thing about this is I can just simply copy this down, right? And I'm always getting the last 3 periods. So there's my moving average forecast. And then, so how accurate, how good is this? Well, I'm just going to skip, in the last video I did, what did I do? I did the forecast error. I hope I convinced you that the forecast error, the average of the forecast error is really crappy because it's got the pluses and the minuses. So I'm just going to skip right to the absolute value, of the forecast error. This is by far a better one. And so remember, we're going to use the absolute value function, ABS, open the parentheses, and here we're just going to take actual sales minus the forecast sales, close the parentheses. And actually, I should tell you, right, if you're going to use, like in this case, if I'm going to use the ABS function, it really doesn't matter if you take forecast minus actual or actual minus forecast, because you're always going to get the positive value, so it doesn't matter which one you subtract from the other. But in the interest of the forecast error, we usually think of that as being actual minus forecast, so I'll stick with that. All right, so here's the absolute value of my forecast error. And then, of course, I can calculate the average of this. So, average. Okay, well, the average here is about 2.6. A little bit, not too bad. We got some 5s and some 4s, but 2.6, not bad. And then, of course, we have our squared forecast error. So, squared forecast error. So, I'll just do that. So, I'm going to take my forecast error, square that, copy that down, and then take the average, and then again, like I was telling you before, I strongly recommend that you take the square root of that. I really do think that's a better measure. Take the square root. So again, I look at this data and I actually think the 3.1 is better than the 2.67. Okay, and then lastly, my percent change. I'm just going to skip right to the absolute value of that percent change. So ABS of percent, it wasn't the change, but percent error. And of course that, as it was before, it's just the ABS of my forecast error. Actually, I don't need to do that. Sorry, because I already have the forecast error is already an absolute value. So I guess I don't have to do anything. I can just take this divided by that, and this is always going to be positive because my forecast errors were already in absolute values. So I can copy that down and then take the average. And there you go. Okay, so here, right, my percent error is 14%. Okay, so what do we got? Well, I have to be honest with you. Yes, this is in the book. Yes, this is one way to forecast, sales in week 13. So if we were going to forecast sales in week 13, right, we would just take the average of the last 3 periods, hit OK, and there you go. All right. Well, so look, I have to be honest with you. I am not a big fan of these moving average forecasts, right? Because if you think back to the last video, why would you just do like a 3-period moving average, a 4-period moving average, so on and so forth, when I can just use the entire data set, right? So the average forecast that we talked about in the last video, right, when I forecasted the week 13 sales, I took the average of all of my sales. That is inherently better than just taking the average of, say, the last 3 or the last 4, last 5, what have you, right? The point is, the average forecast from the last video is going to be, in my opinion at least, better than the moving average forecast because my sample size to calculate that average is larger than this, all right? Yes, some people use it. Yes, it's probably used in the financial planning industry. Okay, fair enough. This is just my personal opinion. I think the actual average forecast that we discussed earlier is going to be better than your moving average forecast, all right? And then lastly, there is something else, I've been telling you, hey, this 2.6 versus this 3.19, you guys do, hopefully you know that you can actually calculate the standard deviation of this forecasting, or this error, and the standard deviation of this error, and see which one is lower, right? The one that's lower is going to give you a better estimate. And to do that, I'll just do it for the, here, I'll do it over here. I'll do it for the ABS forecast error, right? You calculate your squared deviation. So my error minus the average squared right? And then to calculate the variance, I take the sum of all this and divide by n minus 1 because I have a sample variance. So I'll take the sum. Looks like I gotta get it into my recently used. There it is, sum. So I can take the sum of these and then divide by n minus 1. So I've got, well, just to make this easier, why don't I just divide by count, my count function. Count minus 1. There. So that would be the variance of my ABS forecast error. And then I could just take the square root of this. That would give me the standard deviation of the ABS forecast error. And then I could do the same thing. Take this minus this average for my squared forecast error. Square that. Copy that down. And then same thing, take the sum of this. Right, this is just the variance formula from your stats class. The sum of that divided by n minus 1. So that's the count of my observations. Minus 1. And then same thing, take the square root. I don't know what I'm doing, square root. You know, and see, so obviously I was wrong. Here, the standard deviation of my squared forecast error, you know what? I think I did something wrong. Oh, I did. Very, very bad. You have to anchor the mean in both of these. Look at that. I forgot. Boy, that was a mistake. Okay, well, at least this time it's right. But still, you can see that the variation in my ABS forecast error is smaller, right, than the variation in my squared forecast error. So maybe, looking at this, maybe this I am wrong. Maybe the ABS forecast error would actually be better measure of my forecast error because the standard deviation is much smaller than the squared forecast error. All right. Well, at any rate, that's kind of beside the point. That's not in the book. Just a way to kind of measure how good some of these measures of accuracy are. But at any rate, I digress. So here is your moving averages. Yes, I think it's something that you should know. I think it's something you should be able to do. But the truth is, it's not very good. And the other thing, as your book points out, you know, it's like, okay, so in this case, we did a 3-period moving average. Well, why not try a 4-period moving average? Why not try 5 periods, so on and so forth? And even as your book points out, the idea is you use the trial and error method to determine which moving average is better. And that seems inherently kind of like lackluster to me, that, you know, we're just going to use the trial and error method to figure out which moving average is the best. Instead of doing that, why not do what we did in the last video and just take the average of all your observations? Right now we've got n as high as it can be. We're taking into account all of the information that we have on hand. And that's, in my mind, that's the best way to go. Okay, so at any rate, here is your moving average forecast for stationary time series data.